So you do have to be a little careful, especially when you start composing a number of commands. Let's have a look at where this might happen. Here we are composing two assignments. K first gets updated with k plus 1, and then it has to be determined what should be assigned to y. Now if we apply the techniques from the last unit, well, we could expose the weakest precondition going backwards. And then we would say, oh, but that means that the expression e should be x plus k, and that actually could be the end of it. But what if we just push it back a little bit further and say, and then we update k with k plus 1, and if we then blindly just push this through, we end up that e should be equal to x of k plus 1, which obviously contradicts the fact that e should be x of k. So what's going on here? Well, if we look at just that, we would conclude that y should be updated to become x of k plus 1. But if we then go and propagate that back and compute its weakest precondition, we find that x of k plus 1 should be equal to x of k, and then if we propagate it some more, we get that x of k plus 2 should be equal to x of k plus 1. And notice that true does not imply that automatically, unless we have some knowledge about xk plus 2 being equal to xk plus 1, we cannot conclude that this is a correct code segment. So what's going on here? Well, yikes. The issue here is that we notice that k gets updated before y, and therefore if k appears in the expression that's assigned to y, the value that appears there in k might actually have been changed along the way. So what you really want to do is say that y becomes some expression that potentially depends on k. So if we then look and see what the weakest precondition is, we get that the expression which is a function of k is equal to x of k, the array element x of k. And then if you substitute in k plus 1, you notice that e of k plus 1 is equal to x of k. And from that then you conclude that e of k is actually equal to x of k. And now you have a correct code segment, because if you propagate this back, you get that x of k is equal to x of k, and if you then put in the k plus 1, you get that x of k plus 1 is equal to x of k plus 1, and that evaluates to true, and true implies true. So in summary, if you have a sequence of assignments, what you want to do is create a sequence of expressions where for later variables the expression is taken to be a function of the variables to which assignments are made prior to it. And obviously this generalizes when you have more variables involved.